Today we will study about modes of wave propagation, which comes under section antenna and wave propagation. So before going to the topic of today's discussion, we will first know what is antenna. Antenna is basically a passive component which is used to convert electrical signals into electromagnetic wave. Antenna is used to convert electrical signal into electromagnetic waves. So whenever we will be required to transmit a electromagnetic wave, we can use antenna. Antenna will convert electrical signal into electromagnetic waves. So antenna will be used as a transducer which converts electrical energy into electromagnetic energy or electromagnetic energy into electrical energy. Means whenever we will use antenna in the transmitter side, antenna will convert electrical energy into electromagnetic energy, and in the receiver side electromagnetic energy will be converted back into the electrical signal. Whenever we transmit a electromagnetic wave into the space, we need two antennas, one at the transmitter end and another at the receiver end. At the transmitter end, antenna will convert electrical signal into electromagnetic wave, and at the receiver end, electromagnetic wave will be converted back into electrical signal. So antenna is basically a transducer which converts electrical energy into electromagnetic waves or electromagnetic waves into electrical energy. A transducer is a device which is used to convert one form of energy into another form. So antenna can be called as a transducer. It is a transducer which converts electrical energy into electromagnetic waves or electromagnetic waves into electrical energy. Now, a electromagnetic wave is generated using the electric charge. A stationary electric charge produces electric field. A moving electric charge produces electric field in addition to magnetic field. Means a moving a moving charge will produce electric field as well as magnetic field, while a stationary charge produces only electric field. To get electromagnetic wave, the moving charge should vary in speed. Means an accelerating charge will produce electromagnetic wave. So antenna is a device which converts electrical energy into electromagnetic wave. To get electromagnetic wave, we need a charge which should be moving with varying speed. Means if electron is moving with a varying speed, time varying speed, then we will get electromagnetic wave. The cause of electromagnetic wave is accelerating charge. If the speed of charge is increasing or decreasing, then there will be an electromagnetic wave. But if the speed of moving charge is constant, then there will not be any electromagnetic wave. So for electromagnetic wave to be created, we need a charge which should be moving with an acceleration. For example, oscillatory motion. If a charge is oscillating back and forth, then there is acceleration as well as deceleration, and that movement of charge will give rise to electromagnetic waves. So antenna will be used to convert electrical signal into electromagnetic waves, and to convert electrical signal into electromagnetic wave, antenna will cause charges to move with an acceleration. Back and forth motion will be there. There will be an oscillatory motion of charges, and that oscillation of charges will give rise to generation of electromagnetic waves. Now, what is wave propagation? Wave propagation means traveling of electromagnetic wave in space. When antenna will transmit a electromagnetic wave into space, it will travel into the space till the receiver, till it reaches to the receiver. Whenever there will be transmission of electromagnetic wave, it will take place between two antennas, one at the transmitter end and another at the receiver end. So when there will be wave propagation, a wave will be transmitted from transmitter side using an antenna, and it will reach into antenna of receiver side, and that phenomena will be called as wave propagation. Wave propagation means electromagnetic wave is traveling between transmitter and receiver. Now next part of today's lecture is modes of wave propagation. We have seen till now that what is antenna and what is wave propagation. And antenna, I told you that an antenna is a transducer which converts electrical energy into electromagnetic energy, or electromagnetic energy into electrical energy. Means antenna acts as a transducer which converts one form of energy into another form of energy. Antenna can be used as a wave generator, electromagnetic wave generator. Antenna can convert electrical energy into electromagnetic wave. So the next point is what are the modes of wave propagation? Since antenna can be used to generate electromagnetic wave, and that electromagnetic wave will propagate into the space from transmitter to the receiver. That wave propagation has several modes, and that topic will be called as modes of wave propagation. So if you will define modes of wave propagation, you can call it as different ways by which electromagnetic wave travels in space. Different ways by which electromagnetic wave travels in space will be called as wave propagation. Will be called as modes of wave propagation. Modes of wave propagation means different methods by which electromagnetic wave can travel in space. Travel in space in the sense when a transmitter antenna will transmit electromagnetic waves, it can travel in the space till it reaches into the receiver antenna, and the different methods by which this electromagnetic wave will travel between transmitter and receiver will be called as modes of wave propagation. Means different methods by which electromagnetic wave travels in space will be called as modes of wave propagation. These are classified in three categories. Number one is called as ground wave propagation. Number one is called as ground wave propagation. It is also called as surface wave propagation. Number two will be called as sky wave propagation or ionospheric wave propagation. And number three is called as space wave propagation or tropospheric wave propagation. Means there are three methods by which electromagnetic wave can travel in space. Number one is ground wave propagation, number two is sky wave propagation, and number three is space wave propagation. So what is ground wave propagation? What is the difference between these three methods? Basically these three methods are the methods for traveling of electromagnetic waves in space. So first method, ground wave propagation method. Why it is called as ground wave propagation? Because in this method electromagnetic wave travels on the surface of the ground. Means electromagnetic wave literally glides over the surface of the earth. So if electromagnetic wave is traveling the distance between transmitter and receiver by gliding over the surface of the earth, then that method of wave propagation will be called as ground wave propagation or surface wave propagation. So in this particular method, electromagnetic wave is guided through the surface of the earth. Means electromagnetic wave will just walk on the surface of the earth, and that method of electromagnetic wave propagation will be called as ground wave propagation. The problem with this particular kind of propagation is that on the surface of the ground there are high-rise buildings, and those buildings can block the propagation of electromagnetic wave. So this is a problem for the ground wave propagation. To resolve this problem, we generally take low frequency signals. Very low frequency signals are transmitted through this method. The reason behind this is that if frequency is low, then lambda will be high. Wavelength lambda is dependent on frequency, as lambda equals to c by f. If frequency is high, then lambda will be low, and if frequency is low, then lambda will be high. And if lambda, which is wavelength of the signal, is high, it can easily bypass the obstacles available on the surface of the earth. For example, if lambda is very high, then then on the surface of the earth, if there is building, then wave will travel like this. It will just bypass the building, and the surface wave will travel at the receiver. But if the frequency is very high, then lambda will be very low and it will be obstructed by the high rise building on the surface of the earth. So in ground wave propagation, we generally transmit signals of low frequency, and that low frequency is between 0 to 2 megahertz. Frequency of 0 megahertz to 2 megahertz is transmitted using the ground wave propagation method. The reason of 2 megahertz is because at 2 megahertz lambda is enough to cross the high rise obstacles available on the surface of the earth. If frequency will be higher than 2 megahertz, then lambda will be shorter, and they might get blocked by the high rise buildings on the surface of the earth. So this particular frequency cutoff has been selected for the ground wave propagation. In ground wave propagation, electromagnetic wave will glide over the surface of the earth to reach to the receiver antenna, and since it is gliding over the surface of the earth, there are chances that they will be collided with the high rise buildings, and so their wavelength should be in such a way that they could easily cross the high rise building and reach the receiver. If frequency will be high, then that will be blocked by the high rise building and may not reach at the receiving antenna properly. The frequency above 2 megahertz, 0 to megahertz frequency will be transmitted successfully using ground wave. The frequency between 2 megahertz to 30 megahertz is transmitted using second method of wave propagation, and that will be called as sky wave propagation. In sky wave propagation, transmitting antenna transmits the electromagnetic waves into the sky, and in the sky electromagnetic wave through total internal reflection gets reflected back towards the receiver, and receiver antenna will receive. So this method of propagation involves total internal reflection by the sky on the electromagnetic waves. Whenever electromagnetic wave requires transmission using sky wave or ionospheric waves, it is first transmitted from the transmitter, and after transmission, electromagnetic wave will enter into the ionospheric layer of the atmosphere, and this ionospheric layer will cause that electromagnetic wave to refract in such a way that it goes towards the receiver. Means wave transmitted from the transmitter will come to the ionospheric layer of the atmosphere, and after refraction through the ionospheric layer of the atmosphere, it will go back to the receiver antenna. So this method of electromagnetic wave transmission between transmitter and receiver will be called as sky wave propagation, and in this method we use frequency between 2 megahertz and 30 megahertz. The lower frequency is 2 megahertz. The reason behind this is that if you will use frequency less than 2 megahertz, the transmitted electromagnetic wave might get absorbed fully by the gaseous layer of the ionosphere, and that electromagnetic wave will not propagate further. Means frequency below 2 megahertz might get absorbed by the ionospheric layer, and signal may not reach at the receiver end. So we don't use frequency less than 2 megahertz because the energy of the signal is highly dependent upon the frequency. We know the relation energy equals to H into F, means energy is directly proportional to frequency. Higher the frequency, higher will be the energy. Lower the frequency, lower will be the energy. If frequency is less than 2 megahertz, energy will be very low, and that low energy signal might get absorbed by the ionosphere in the gaseous layer of atmosphere, and will be lost and would not be able to reach at the receiver. However, frequency after 2 megahertz up till 30 megahertz have enough energy to cross the ionospheric layer, and after total internal reflection through the ionospheric layer, the signal will be reached on the receiver side. So we are basically using here lower cutoff frequency to avoid absorption by the ionosphere Upper cutoff frequency is being used here because if frequency is too high, then electromagnetic wave will have energy very high, and that high energy might penetrate the ionosphere, and electromagnetic wave will enter into the space and will never return to the receiver. So if frequency is very high, it might penetrate the ionospheric layer of the atmosphere, and the signal may not return back towards the receiver, while if the frequency is very low, that signal will be absorbed by the gaseous layer of ionosphere. So the energy of the signal should be such that it gets reflected by the ionosphere. It achieves total internal reflection by ionosphere. That means the frequency should be between some lower and upper cutoff frequency, and that lower and upper cutoff frequency are 2 and 30 megahertz for skywave propagation. So I have told you about two methods of wave propagation. I have told you that a electromagnetic wave travels between transmitter and receiver. Different methods by which electromagnetic wave travels between transmitter and receiver will be called as modes of wave propagation. Different ways by which electromagnetic wave will travel between transmitter and receiver will be called as modes of wave propagation. Modes of wave propagation have been divided in three categories based on their frequencies. For 0 to 2 megahertz frequency, we use ground wave propagation. In ground wave propagation, electromagnetic wave glides over the surface of the earth. Means electromagnetic wave just walks over the surface of the earth, just travels over the surface of the earth. And since electromagnetic wave is traveling on the surface of the earth, if there is a high-rise building on the way, that high-rise building may block the propagation of electromagnetic wave. So wave should be in such frequency range so that it could cross the building, and that frequency range is 0 to 2 megahertz, because lower the frequency, higher will be the ability of bypassing the obstacles on the earth. 2 megahertz is the highest frequency which is suitable for the ground wave propagation. 2 megahertz will give rise to high value of lambda, and if lambda is high, then it can easily cross the obstacles available on the earth. If lambda is low, then signal might get lost very soon on the surface of the earth. So for high lambda, frequency should be low, and that low frequency is 0 to 2 megahertz. The second method of traveling of electromagnetic wave between transmitter and receiver is sky waves. In this mode of propagation, electromagnetic wave is being transmitted into the sky, and that electromagnetic wave is being refracted back by the gaseous layer of the sky, also called as ionosphere. Different kind of gaseous layer is available in the sky, and when we when we move from low height to higher height, when we move into the sky from the surface of the earth, the atomic density of the air decreases. Since the medium density is decreasing, the electromagnetic wave will travel in such a way that it refracts away from the normal, propagating from the surface of the earth and entering into the sky. Electromagnetic wave will always bend towards the earth. This bending of the electromagnetic waves is because of rarer medium in the sky rather than on the surface of the earth. Due to refraction, electromagnetic waves refracts away from the normal and bends in such a way that it reaches to the receiver. That kind of bending of electromagnetic waves will be achieved through the gaseous layer of sky waves, and this kind of propagation uses 2 to 30 megahertz frequency range. 2 to 30 megahertz frequency has been defined on two regions. If frequency is very low, energy will be very low, and low frequency signals are absorbed by the ionosphere and lost in the ionosphere, and that's why we use a minimum frequency. Minimum cutoff frequency is 2 megahertz for skywave propagation. If energy is very high, then that signal might penetrate the ionosphere of the atmosphere and enter into the space and never return. So that energy should not be used in the skywave. So the maximum limit of frequency is 30 megahertz. Up till this frequency, energy of the electromagnetic wave will be such that electromagnetic wave will not be able to penetrate the sky wave, penetrate the ionosphere, and therefore it will definitely come back after refraction towards the receiver side. So this is the range which is used in sky wave propagation. This is the range which is used in ground wave propagation. Now the frequencies over 30 megahertz will be used in third method of wave propagation. If frequency is greater than 30 megahertz, then wave is transmitted by using space wave propagation. Space wave propagation is basically line of sight propagation. In this particular wave propagation, transmitter antenna and receiver antenna can see each other, means they are in the line of sight and they can see each other. So high frequency signals above 30 megahertz signals use line of sight propagation, and those line of sight signals are transmitted using space wave propagation. Basically, in this particular propagation method, antennas are fixed on the high rise buildings in such a way that each transmitter and receiver both antennas can see each other, or it can be used in space wave propagation in satellite communication. One transmitter will send signal through satellite, and satellite will send those signals to the receiver. So again, line of sight will be followed. In space wave propagation, signals will be transmitted from transmitter to receiver. In that case, signal will directly reach from transmitter to the receiver. That will be called as direct wave through line of sight communication. And another signal will be the reflected signal from the ground or earth. When signal will be transmitted from the transmitter, it will reach directly onto the receiver, and it will collide with the earth surface and reflect back, and will go to the receiver end. So two kinds of signals will be received at the receiver: direct wave and reflected wave. Reflected wave is that wave which is coming from the earth surface after reflection, and direct wave is that signal which is coming directly from the transmitter to the receiver. Now you can see in this diagram that this is the surface of the earth, and this is the ionosphere, spheric layer. This is the transmitter antenna, this is the receiver antenna. When electromagnetic wave is transmitted from transmitter antenna, it enters into the ionosphere. It enters into the ionosphere, and through refraction phenomena, this wave is turning away from the normal. This wave is turning away from the normal and bending towards the earth. This is because in the ionosphere, density of medium will go on decreasing. Near the earth surface, density will be higher, and near the above the earth surface, density will go on decreasing, and due to medium change from denser to rarer, electromagnetic wave will turn away from the normal, and electromagnetic wave will keep on bending, and after bending it will reach to the receiver side. So this is the receiver side, and this is the transmitter side, and this is the way by which wave is propagating. Here wave is using the phenomena of total internal reflection. Total internal reflection. In this this phenomena occurs when wave enters from rarer medium to denser medium to rarer medium. So this is the diagram representing ground wave propagation as well as sky wave propagation. In ground wave propagation, this is transmitter, this is a receiver. You can see here that electromagnetic wave is gliding over the surface of the earth. Electromagnetic wave is gliding over the surface of the earth. This kind of propagation will be called as ground wave propagation, and this kind of propagation will be called as sky wave propagation. So you can see the effect of ionosphere on the electromagnetic wave, and its effect of the earth on the electromagnetic wave. When electromagnetic wave will glide over the surface of the earth, it will be called as ground wave propagation. When electromagnetic wave collides with the surface of the earth, it tilts. Wave fronts get achieve tilting. Tilting means electromagnetic wave which was having vertical electric field on the surface of the earth will get some tilting, and due to that tilting, tangential component of electromagnetic wave will be cancelled out because of image current available near the surface of the earth. Image currents are associated with the ground wave propagation. Basically, whenever we transmit electromagnetic wave, near the surface of the earth, suppose this is earth surface, then equal and opposite wave induces in the earth surface. And suppose this is positive, this will be negative, this is negative, this will be positive, this is positive, this will be negative, this is negative, this will be positive, this is positive, this will be negative. So when they will be close enough, they will be short circuited, they will combine and eliminate. So due to tilting, tangential component of electromagnetic wave get cancelled, and due to this ground wave propagation causes electromagnetic wave to reduce to zero after propagation of certain distance. Means ground wave propagation due to this image current, due to this induced EMF, will eventually become zero after propagation of certain distance. This is acting like a friction, just like when we throw a ball on the surface of the earth. After some time, ball has to be stopped. The reason behind this is friction. Just like the friction, here image current in the earth is causing ground wave to gradually decrease, and eventually it will become zero. I have told you that in ground wave propagation, the electromagnetic wave will glide over the surface of the earth. Glide over the surface of the earth means electromagnetic wave will travel on the surface of the earth. Electromagnetic wave will walk on the surface of the earth, and in this phenomena, it will collide with the obstacles available on the earth. And to avoid signal loss, we use frequency below 2 megahertz. Means 0 to 2 megahertz frequencies are used in ground wave propagation. More strongly diffracted around the obstacles due to their long wavelengths. This is because they are more strongly diffracted around obstacles due to their long wavelengths, allowing them to follow the Earth's curvature. The Earth has one refractive index and the atmosphere has another, thus constituting an interface that supports the surface wave transmission. So this was all about ground wave propagation. In ground wave propagation, wave glides over the surface of the earth. Frequency range is 0 to 2 megahertz. If frequency is low, lambda will be high. If lambda is high, it can easily cross the obstacles available in the way. Now, this diagram is representing sky wave propagation. You can see here in this diagram, this is the transmitter, this is the receiver. Transmitter is transmitting the signal. You can see that signal 1 is getting refracted back towards the receiver. Signal 2 is also getting refracted back towards the earth, but signal 3 is penetrating the ionosphere and entering into the space. This wave will never return. This wave will not return back to the transmitter. The reason behind this is that this wave, this electromagnetic wave, has enough energy to penetrate the ionosphere. So sky wave propagation should have energy threshold in the form of frequency. So sky wave propagation is basically in the range of 2 to 30 megahertz. Frequencies above 30 megahertz will cross the ionospheric layer and enter into the space. This is the diagram representing sky wave propagation. In sky wave propagation, basically electromagnetic wave is getting reflected back by the ionosphere. Ionosphere is the gaseous layer available in the atmosphere, and that gaseous layer is causing electromagnetic wave to refract and bend in such a way that it reaches the receiver. This kind of propagation of electromagnetic waves between transmitter antenna and receiver antenna will be termed as sky wave propagation. This phenomena has been further explained in this diagram too. You can see that there is a transmitter, there is a receiver. When wave is being transmitted, it enters into the ionosphere. In ionosphere, it is turning away from the normal. You can see that wave is bending, turning away from the normal. This is because ionosphere is having a lower density of atoms in the upper side and higher density of atoms in the lower side. Wave is getting refracted because wave is passing through denser to rarer medium, getting away from the normal, and after getting away from the normal, it is completely returning to the medium 1 and receives at the receiver point. This phenomena of wave propagation, the method of wave propagation using ionosphere will be called as sky wave propagation. Now there is a term called critical frequency. Critical frequency is the highest frequency which would be returned by the ionosphere. Highest frequency which would be returned by the ionosphere after refraction will be called as critical frequency in vertical incidence. So suppose this is ionosphere and you are transmitting a signal vertically. If it gets returned, then the highest frequency for which this phenomena is happening, that will be called as critical frequency Fc, and it equals to 9 square root nm. Means it depends upon the charge density available in the ionospheric region. In ionospheric region, due to sunlight, atoms get ionized and there are large number of free electrons. Higher the number of free electrons, higher will be the critical frequency. Lower the number of free electrons, lower will be the critical frequency. In the daytime, due to sunlight, ionization is high, so large number of electron densities, large number of electrons will be there, so electron density will be high in the daytime and lower in the night time, because in the night there is no sunlight. Ionosphere region has been categorized between 70 to 400 kilometer above the earth surface. Means height of 70 kilometer and 400 kilometer constitutes ionosphere, and from this ionosphere wave is getting refracted in the ionospheric wave propagation. The frequency of ionospheric wave propagation is 2 to 30 megahertz, and this is also called as short wave propagation, because frequency is high, so lambda will be low, called as short wave. This is the structure of the ionosphere. You can see that there are several layers, and these layers are based on the electron density. You can see that there are D layer, there is E layer, there is F1 layer, there is F2 layer. These layers are having different electron densities. In the daytime, in the day hours, due to sunlight, electron density will be higher in the upper layers, and in the night time, electron density will be lower because of recombination. So in the daytime, electron density will always be high, and at noon it will be maximum. In the night, electron density will always be lower. But in the D layer, electron density will be least. In the F layer, electron density will be maximum. The reason behind this is that sunlight falls with high intensity in the upper layer and lower intensity in the lower layer. Intensity of sunlight becomes weak in the near the earth, and it is very high in the upper layer. So in the upper layer, chances of ionization is very high because of high intensity of rays coming from the sun, and therefore electron density will be high in the F layer and low in the D layer. During night time, D layer electrons get combined, and D layer eliminates completely in the night. The reason behind this is that in the lower region there is high density of atoms, and due to high density there is high chances of collision, and ionized atoms can easily collide with each other, and electrons will further get recombined. In the upper layer, atoms are far away, so chances of collision is less and recombination is therefore less, so density will remain high. In the these layers will therefore be available in the night as well as in the day, while D layer eliminates in the night. This is the density of electrons. You can see that in the D layer, which is the layer between 50 to 90 kilometer from the Earth's surface, this density is appearing in the daytime, while in the night D layer is disappeared. Similarly, E layer is available in the daytime. E layer is also available in the daytime, but F1 and F2 layers have been combined. Third one is space wave propagation. I have already told you that in space wave propagation we do line of sight propagation. In line of sight propagation, transmitter and receiver can see each other, and the frequency range for this wave propagation is above 30 megahertz. This kind of wave propagation is used in satellite communication, radar communication, and microwave communication. In this wave propagation, antennas are fixed on the top of the high-rise buildings, which can see each other. Antennas can also communicate with the satellite, and satellite can also communicate with the receiver. So when a signal is transmitted through line of sight propagation, that method of wave propagation is called as space wave propagation.